Okay, today's lesson is on inverse functions, so 6.7. There's a handout that goes with this one. This lesson's a little bit long. We're going to just go through everything today, and then tomorrow you will have a work day on your homework. Okay, so an inverse relation would map the output values back to their original input values. So as a result, your domain for your inverse function will be the range of the original relation. I was saying function either way. And the range of the inverse relation is the domain of the original relation. So your domain and range will switch from the original to the inverse and vice versa. So using this table below, here's my original function. So we're going to see f of x used to represent the original function, and then the inverse would be f to the minus 1 power of x, and that means inverse. So you're going to see both of those notation. Okay. So if your domain and range switch, remember x represents your domain and y would represent your range. So if I'm switching those, I'm really just switching the points around. So instead of -1, 4, I have 4, -1. Instead of 0, 7, I have 7, 0. Instead of 3, 2, I got 2, 3. And 5, 1 would be 1, 5. All right, so they just swap. And this is just a little visual over here. So my input would go into the original. So what you plug in, here's what you get back out. And then it just kind of flows through with the inverse. And this f to the minus 1 of x means inverse. So that's important that you understand that means inverse when you see it. Okay, so next we are going to find each of these equations. These are the original equations. We are going to find their inverses. So I'm going to go ahead and swap x and y. Since the domain and range switch, I can switch those variables, and then we'll solve for y. And we're also going to look at finding the domain and range for the original and the inverse. So with my first problem over here, y equals 3x plus 6, that would be a linear equation. And so I'm going to switch the input and output and then solve for y so I can rewrite this. So then I'll subtract 6 from both sides. So x minus 6 would equal 3y. And then to get y completely by itself, I'll divide by 3. So you can write this in a couple of different ways. You can write it as y equals x minus 6 over 3. Okay. If I were to graph this, because in some cases we're going to graph some of these inverses, it would be more beneficial if I divided my x by 3 or turn it into 1/3 x and then take 6 and divide by 3, and that would be minus 2, because that's going to be a better equation to graph. My slope would be 1/3, my y-intercept would be -2, and then f to the minus 1 of x, that would represent your inverse. Okay, so when we're finding the domain, make sure you're paying attention to domain of the original, range of the original, domain of the inverse, range of the inverse. Okay, so if I'm talking about domain first for my original function, y equals 3x plus 6, remember that just makes a straight line. So really your domain and your range would be all real numbers for both, okay? And if your domain and range switch, it's going to be all real numbers for both again, or this is going to be another line, another diagonal line, where your domain and range would be all real numbers. So lines aren't too interesting for switching up things with the domain and range. Now with my next example, it'll be slightly more interesting. Let's go ahead and find that inverse. So if I switch my input and output, then I will take away 3. So x minus 3 would equal y squared. And then to get the y all by itself, I will take the square root. Now I need to remember, just like when we solved equations and I had something like y squared equals 9, there were two things that made that true, both 3 and -3, so both positive and -3. So I need to make sure I remember that there would be two things that make that true, both positive and a negative in front of that square root. Okay, so my inverse equation would be plus or minus the square root of x minus 3. So now if I go back to my domain and range, so this is a parabola. The hope is that when we see x squared, we know that means this is a parabola. It's moved up 3. Parabolas would be all real numbers. Little sketch of that graph. If I move it up 3, little U shape, open up. The range then would be y must be greater than or equal to 3, because 3 would be the lowest value. So if I know my domain and range of my original function, I can come up with the domain and range of the inverse. Okay, so if my domain's all real numbers, my range will be all real numbers. Okay, if my range for my original is y is greater than or equal to 3, that is going to be the domain of my inverse, but domain would use x. And then hopefully this makes sense, especially from last week's unit or last week's lesson on graphing your radical functions. You had to come up with domain. So I can't have any negatives inside of that square root. So that would mean all my numbers have to be greater than or equal to 3, because 3 minus 3 would make that 0. Anything smaller than 0 would be a negative number. When we don't have that plus or minus in front, that's just going to be that little half parabola graph. When you have the plus or minus, it's going to be both sides of that. Okay, so that would make this range all real numbers, versus if it didn't have the plus or minus, it would have only been y is greater than or equal to 0. Okay, let's look at our next function here to the right. So f of x equals 2 times the square root of x. You can replace the f of x with y if that helps you, and then swap your x and y. Here, I'm going to go ahead and divide by 2 first. And now I'm going to square my square root and make sure I square the left side, everything on the left side. So that would be an x squared over 2 squared would be 4 would equal y. So we could write it in that way. We could write it as 1/4 x squared to make it look more like the form for a parabola. So my domain of my original function, now I have a square root, so there's going to be restrictions on that domain. I cannot have any negatives. So that means x must be greater than or equal to 0. So if I know the domain of the original, I've got the range of the inverse, but I must use y, which hopefully that makes sense because this would be a parabola. It doesn't get pushed anywhere up or down, so it would be at 0, 0, and it would just be narrow. So y must be greater than or equal to 0 for that range. If I look back, we've already looked at how you graph something like that. That doesn't move anywhere left or right. So the range for that graph would be y must be greater than or equal to 0. Now here's what's tricky, is that means the domain of my inverse is also x is greater than or equal to 0. Now, a lot of students would be confused by that because a parabola would be all real numbers, but my inverse would be a half of that parabola. Since the original function is half a parabola because there's only a positive here, so when I flip that over, that would be the other half of that parabola. And we'll talk more about the graphing in a little bit here. Okay, so we have to pay attention to the original function domain and range to help us find the inverse domain and range. All right, so for what we just looked at the earlier problem that f of x equals 3x plus 6, we know that would be an inverse of 1/3 x minus 2. If we use composition, so that's when I plug a function into another function, but I know the input that I'm wanting to plug in, something special will happen. So if I plug 5 in for the x in the inverse problem, so I'll take 1/3 times 5 minus 2. So this would be 5/3 minus 2. If I want to go ahead and just do little common denominators quick. So that would be 5/3 minus 6/3 be negative 1/3. So that means f inverse of 5 equals negative 1/3. So I have this value is negative 1/3. So now I'm plugging in negative 1/3 in place of the x in f of x. So here's my f of x. So 3 times negative 1/3 plus 6. So if I take 1/3 of 3, that would just be 1, but it's negative. So negative 1 plus 6 is 5. So I went through that pretty quick, but what I want you to see is that what I plugged in was 5, and what I got back out was 5. Okay, that will happen every time you plug an inverse function into its original function or the other way around. Okay, because we are switching your domain and range, when you're plugging it inside of each other, you're just going to get the same result back. Okay, so if we perform composition using 2 inverse functions, we will always get the same result that we plugged in. So if I had f of inverse of 3, no matter what functions it are, that would be, if they are both inverses, that will always be 3. And so that means for any value of x I plug in, I'm going to get x back out. So what we're going to do next is verify by composition that these functions below are or are not inverses. So I must show both ways. So I will do f of g of x. I must show that it equals x because I'm plugging g of x in place of the x in f. So I am taking my g of x is the x squared plus 4. And that's going to go in place of the input in f of x. So f of x equation uses a square root. The input is x, so I'll replace that with x squared plus 4, and then I take 4 away. So that would give me just x squared, because 4 minus 4 would be 0. The square root of x squared would give me x. So I just showed that when I plug in g of x into f of x, I get x. So then I need to also show it the other way. So I need to show that g of x, g of f of x would equal x, g of f of x. So my f of x is the square root of x minus 4, so that's going to replace the input in g of x. So when I plug things into g of x, I square it, and then I add 4. So I'm going to plug in the square root of x minus 4. I'm going to square it, which would cancel out my square root. So then I'd get x minus 4 plus 4, and negative 4 plus 4 would be 0. So I just showed that I get x when I plug in the function into its other function. So they have to be inverses. Okay, if I try that with my second example over here, I do f of g of x to start. So g of x is my 7 minus 2x. So I need to look at this function. That x is going to be replaced with 7 minus 2x. And then I will add 7. So if I distribute that, I'd get 14 minus 4x plus 7. So 21 minus 4x. That does not equal x, so I did not get back out what I plugged in. Those two equations would not be inverses. I don't need to necessarily, so these were inverses. And these are not inverses. I don't necessarily have to find the other one. In Math Excel, it might ask you to find both and then say yes or no whether they are inverses. I can't remember. But if you were doing something on paper and they were not inverses at this point, I wouldn't make you do the g of f of x because we already know they don't work. Okay? So you have some of that to do. Next, I want to look at graphing. So you'll be given questions where it's going to ask you, is the original relation a function? Is the inverse a function? So we talked about this, just an original function. We can use the vertical line test. We talked about our functions lesson with domain and range before we got started in the second part of chapter 6. So if a vertical line passes through your relations graph more than once, then the relation is not a function. Okay, so if I look at my first graph, I've got this parabola here. Vertical line test would pass. Original relation is a function. Okay, I've got this diagonal line here. Original relation would pass a vertical line test. That is a function. I've got kind of, looks like maybe one of my square root graphs. Pass a vertical line test. That relation is a function. Okay. So now, is the inverse a function? We can use a horizontal line test. If the horizontal line passes through a relation's, I should say, original graph more than once, then the inverse of that relation is not a function. Okay, so if I look at my parabola and I look horizontally, it would pass through more than one point. So the inverse of a parabola would not be a function. Okay, horizontally, it would pass for any line as long as we don't have horizontal and vertical lines. For my next one, here's my little, it does pass. Some students might think that part right there, but it's just slowly, it's just so gradually getting away from that starting position that it almost looks like it wouldn't pass horizontally, but it does. So that would be a function. Okay, we're going to look at graphing the inverses, and then we'll talk about how we've already looked at points on a graph that just switch the x and the y. You switch your input and your output. So these diagonal lines right here are to represent that you're going to reflect this parabola over that line, so it kind of just ends up with this sideways looking parabola, which is why that is not a function. Okay, so we're going to look at that here next. All right, so here's my last two examples. Like I said, kind of a lot to talk about today, so hopefully you're still with me here. So we're going to look at graphing a line with its inverse, its original, and then talking about all the domain and ranges of everything and if it's a function. And then we're going to do that with my second example as a parabola. Okay, so let's go ahead and graph my line. So I've got -2 for my y-intercept, and I've got a slope of 4. So I will rise 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. All right, that's my original problem. My domain and range would be all real numbers. So that is also going to be the domain and range for my inverse, since the domain and range just swap. Okay, I could answer, is the inverse a function at this time? Because it would pass a horizontal line test, so both the inverse and the original are functions. So I can find all that information out before I've even found the inverse function, and then we'll go ahead and find that. So I'll switch my x and my y. So if I add 2, divide by 4, you can leave it as x plus 2 over 4, but I'm going to be graphing this, so I think it would be more helpful if I write this as 1/4 x plus a half, because I take my 2 divided by 4. So it's a little bit messy, not a big deal, but so a half for my y-intercept, and then from there I'm rising up a full, not a box this time, because I'm rising a full length of a box, so I'm going to land in the middle, and then 1, 2, 3, 4. So what I was talking about on our previous example is that the line y equals x would be the line that this is reflecting over, okay, to get that inverse, because we are switching those x and y values. Something else you could have used to graph this line is you could have taken, we've got 3 points on this graph, and so this is the point here, 0, -2. So that means on my inverse, I need the point -2, 0, which would be here. Okay, so I could also do that to graph it if I wanted to. Okay, let's take a look at number 2 for our last example today. And I'm going to go ahead and graph this parabola. So hopefully remember how to graph that. My vertex would be 2, 1. Okay, from here, if you remember the pattern of points, my A value is just 1, so it's going to have that continuous pattern of over 1, up 1, over 2, up 4. If you remember what I'm talking about, great. If you don't, then you need to plug in a value for x, like when we made tables. So if you plugged in, let's say 0, 0 minus 2 squared would be -2, squared is 4, plus 1 is 5. So when I plugged in 0, I got 5. So I've got the point 0, 5. Match 1 on the other side was another method we used to look at that. So here's my parabola. Okay, so my domain would be all real numbers. My range, my lowest value for the y would be at 1, so y must be greater than or equal to 1. So once we have those things, I can answer these 3 right now without even having my inverse function. Okay, my domain has to be my range, so that will be now x is greater than or equal to 1. My range would be all real numbers, and this would not be a function because it would not pass the horizontal line test on the original parabola. My parabola is a function, but this is going to be a parabola on its side when we graph the inverse. Okay, so let's take a look at what that inverse function would be. So I'll swap my x and my y. So I want to subtract 1 here. Now this kind of confuses students quite a bit. A lot of them want to take y minus 2 times y minus 2, but you're going to get y squared minus 4y plus 4. So you're going to get multiple y's. So then you will not be able to get y by itself. So you must actually take the square root first to undo that it's being squared. Then we need to remember there are 2 values, so both positive and negative go in front of your radical. And then I've got x minus 1 equals y minus 2. So I'm going to have plus or minus the square root of x minus 1, and then I will add 2. And that would be outside of your radical. So if you think about how we graph problems like this when we have the radical equations for section 6.8, I had to go right 1 up 2. So that's kind of my new vertex, but this graph is on its side. So when we graphed these before, 1, 2, 3, 4, up 2, that's how you would have graphed this radical if there wasn't the minus attached to it. There is a minus, so we will have to do the other side. So I really just have a parabola on its side. Okay, so that sideways parabola is not a function. Okay, we know that from looking at the inverse graph because it wouldn't pass the vertical line test. And I know it by looking at the original functions graph because it doesn't pass the horizontal line test. Okay, another way you can graph the inverse as well, you've got these 5 points from your original function. So I've got the point like 0, 5. I've got the point 1, 2, 2, 1. So then on my inverse, I'd have the 0.50, 2, 1, 1, 2. Okay, which I already have my 50, my 1, 2, my 2, 1, and then we can get the other points as well. Okay, so a couple different ways you can graph that inverse. Okay, it's a lot of stuff. Tomorrow we will do a little bit of review together, and then it'll just be some work time to get through this homework assignment. If you can get it started today, that would be great, but bring those questions tomorrow if you are still having trouble with this. All right, good luck.